Hello, this is Dr. C. We're going to talk about thread creation in Java, and we're going to look at how to do it via subclasses of the class thread. So the basic idea is to create a subclass of the class thread and override the run method. So the thread class has a default run method that does nothing. You simply put the code that you want to run in a separate thread into the run method, and we're just then about ready to go. So here is a little example. We're going to have a class called simple thread, which extends thread. It is going to track, each instance of this class is going to track its own internal name, which we get by passing some string into the constructor. And then, just like we do for a regular method, we provide a public void run method, but now this is special because it's part of the thread class. And in this separate thread of execution, our little program is simply going to print out its internal name 5 times. Now, to actually trigger the execution of the thread, what we need to do is tell the thread instance to start. So we send it a start message, we execute a start message, which then indirectly works its way down through the operating system, which then turns around and executes our run method. So it's basically a two-step process. You say to your object instance start, and at some point in time later, the operating system will execute that code based on your run method. Here we see a simple thread test program that actually puts these thread instances through their paces. So we had a simple thread class, and here we are in this main method creating 3 instances of the simple thread class. One which is passed a string sun, another is passed a string Java, and another is passed a string beans. So we've got our 3 instances. Then we say to each instance start, and that is the trigger to the operating system to begin to execute these threads. Now what happens is these 3 threads that we've started go into what is called the runnable pool. The pool of threads that the operating system scheduler can pick based on its own internal algorithm. So the issue here is we cannot predict when any one of these threads is going to run, when it's going to be interrupted, when the CPU is going to be given to another thread. We're in the uncertain land of multi-threading, which is both its beauty and its potential complexity. Here we see the result of that execution. So we're looking at the individual run method, and on the right we have the output of the program. And as you see, the thread that's printing the word sun gets to execute 2 cycles of its for loop, at which point it's interrupted, and the thread that prints the word Java is given a chance to run in the CPU. It begins to iterate its own loop in its own thread of execution. It does it 3 times. Then it gets taken off the CPU, and the sun thread gets to execute maybe 1 time, and then the beans thread executes a couple of times. So the idea here is that there's an interleaving of the output based on the 3 threads that are running within this program. And if we run this again, the output would be expected to be different because the scheduler runs on an algorithm that we cannot estimate, we cannot use in any way to predict the outcome of threads. So the basic idea here is don't try to outguess the scheduler. So this is what threads would look like having been created via extending the thread class.